Hello, welcome back. This is a video over Unit 8, Section 2, and we're going to be talking about parallel lines cut by a transversal. So in the last video, we talked about two lines being cut by a transversal, but in this case, we're going to be talking about parallel lines being cut by a transversal, and that's going to have a lot of unique relationships. And so let's get started. All right, so defining parallel lines. So what we want to do is talk about parallel lines. Parallel lines are lines that do not intersect and are coplanar, okay? And I'm going to add in that they run side by side and never touch. So they're side by side and do not intersect. Okay. And so one thing that we would use to show that two lines are parallel is this notation here. So these two lines indicate that lines M, so this is line M, and line N are parallel, so indicate parallel. So that's the symbol we would use. And that's two lines just running up and down, so M is parallel to N, and that's how we'd read that. You can also use the arrows here indicate that they're parallel. So you can look at a picture, and if they, if you have two arrows indicate that they're parallel, even if you had one arrow, that would indicate that they're parallel, okay? So let's take a look at angle relationships using lines cut by a transversal. And in this, you have two parallel lines, and I know that they're parallel because of my arrows here, okay? When I see those arrows, I know that they're parallel. Here's my transversal line T, okay? We've got angles 1, 2, 3, and 4. Now, we're going to talk about three different types of angle relationships. The first one is corresponding angles, alternate interior angles, and alternate exterior angles. Now, I'm not going to go through what those are because that's what I did in the last video, but when we have parallel lines, we have congruence statements, okay? So here's what I got. And I'm just going to go through this logically with you for a minute here, okay? When I look at this, angle 1 here, all right, corresponds with angle 2, okay? Knowing that these two angles are congruent allows us to then say, all right, well, angle 1 is congruent to angle 3 because they're vertical angles. We learned that in the last section, okay? And then I can apply the same thing over here with angles 2 and 4. They're vertical angles. So angle 4 would have to be congruent to angle 2. Now, when I use one arc mark to show that these angles are congruent, then all of these angles are going to be congruent to each other, okay? Which is one of the cool things about parallel lines being cut by a transversal is that if I know one angle, I can then name these other three angles and know what they are, okay? So what we can say is, using that concept of just corresponding angles are congruent, angles 1 and 2, and using the concept of vertical angles being congruent, then I know that, not only corresponding angles 1 and 2 are congruent, but that if I have alternate interior angles, angles 2 and 3, that those are congruent, and alternate exterior angles 4 and 1 are also congruent, okay? That's the idea. All right, so let's talk about each of these individually. All right, so corresponding angles, all right? So we talked about this in the last section, but when we're talking about parallel lines being cut by a transversal, then we can say that corresponding angles are congruent. So over here, corresponding angles are congruent, all right? And it's important that we know that in this scenario, okay? So parallel lines, when they're cut by a transversal, angles 1 and 2 are going to be congruent, okay? And that would work for any other. Let's say you had 3 and 4. Those angles would be congruent, okay? And in this, I'm using two arc marks because those are a little bit different, okay? So if I were to create angles inside of this picture, those two angles would also be congruent, okay? All right, so let's look at this problem here. Corresponding angle relationship. So what we know, if two parallel lines are cut by a transversal, the corresponding angles are congruent. If two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So what we can say here is that, we have this picture. We have lines A and B, and they're being cut by a transversal. So this angle here, 62 degrees, top left corner, corresponds with angle 1 over here, which is also in the top left corner of the intersection, okay? So the question is what must angle 1 measure, what must the measure of angle 1 be for lines A and B to be parallel, okay? So remember, if these angles are congruent, then these lines are parallel. So angle 1 would need to be equal to 62 degrees, all right, for those to be parallel. So if these angles are congruent, then we know that these lines are parallel, okay? And that's the idea, all right? All right, so corresponding angles, we know that those are in the same position of each intersection, okay? So in this example, angle 1 and 48 degrees are corresponding angles, okay? 2 and 132 degrees are corresponding. Angle 1 is in the top right, 48 degrees is in the top right. And I'm talking about the intersection, okay? Angle 2 is in the top left, same with 132 degrees. So what I know is that, angle 1 in this case would be equal to 48 degrees, okay? And I know that angle 2 would be equal to 132 degrees, okay? And you can come in here and you can draw in your arc mark. One arc mark indicates that those are congruent. Two arc marks indicate that these two angles are congruent, okay? So given that A is parallel to B, what can you conclude about corresponding angles? And that's that they are congruent, okay? So corresponding angles, these angles are congruent, all right? So that's the idea for that. Let's take a look at the next page. All right, so on this part, alternate interior angle relationship. So if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. If two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. So all I'm saying in these things is just going one way and going the other. All right. So if two lines are parallel, cut by a transversal, alternate interior angles are congruent. By knowing alternate interior angles are congruent, then these lines are parallel. Okay. So in this example, okay, you have these two lines, A and B, they're parallel. All right. And you have a transversal. Looking at this diagram, I know that these two angles are congruent, okay? So if I come in here and here, all right, those two angles are going to be congruent. So what I know is that angle 1 is equal to 42 degrees, all right? And so all I'm doing is just looking at this photo and saying, oh, these are alternate interior angles, okay? And these lines are parallel, so I can automatically tell what angle 1 is. Here's the thing. Okay, what information is contradicting in the diagram? Well, here's what I know, is that these two angles here are supplementary. They form a line, okay? These two angles should add up to 180 degrees. So if I take 137 plus 42, I should get 180 degrees, okay? So if I take 137 plus 42, that's actually going to give us 179 degrees, which is equal to 180 degrees, okay? So that's what's contradicting in this diagram, okay? So this is actually an incorrect diagram, okay? So you can check to see whether the lines are parallel or the angles or whatever. So because of this, all right, these lines wouldn't be parallel. Okay, so it's incorrect. All right, so let's take a look at some things about alternate interior angles. All right, now over here, all right, taking a look at this example, we want to find the measures of angle 1 and angle 2, okay? So what we can do is we know these lines are parallel. Notice that in this diagram that you have a pair of corresponding angles here and a pair of corresponding angles here, okay? So what we can do is we can use the concept of alternate interior angles to figure out what angles 1 and 2 are, okay? Now, if I look at angle 2, its alternate interior angle is 132 degrees, okay? So I'm going to come in here. I'm going to label this here, but I'm going to say that angle 2 is equal to 132 degrees, okay? I can also come in here and say angle 1 is an alternate interior angle to 48 degrees. So I'm going to say that angle 1 is equal to 48 degrees. Now, the other thing that you could have done is use vertical angles to figure that out. Because up here you're given these angles, knowing that the angles that are across from each other, you could come to the same conclusion, okay? But alternate interior angles, when two lines are parallel cut by a transversal, they are congruent, okay? And that's the idea, all right? Now we can apply the same thing to alternate, hold on, before we do that, one thing to check here is to verify that 132 plus 48 is 180, and that's true, okay? So 132 plus 48 is equal to 180. 48 plus 32 is going to give us, in fact, 180. 132 plus 48, 180 equals 180. All right, so that's true. So this checks out and this works, okay? Over here, let's talk about alternate exterior angle relationship. So same thing applies, okay? That alternate exterior angles are congruent if the lines are parallel. So 62 degrees is an alternate exterior angle to angle 2, okay? And then angle 1 is an alternate exterior angle to 118 degrees, all right? So knowing that, all right, here's what I got. That this is going to be 118 degrees and that this is going to be 62 degrees, okay? So we wanted to determine if these lines are parallel, okay? Now, here's what I want to verify. Do these two angles add up to 180, okay? Because if they're congruent over on this side and this side, then, then they should still just add up to 180 and we should be good. So let's take 62 plus 118. Do we get 180? Okay, that's the question. So 62 plus 118, 2 plus 8 is going to give me 10. So 120 plus 60 is 180. So yes, this does check out. 180 is equal to 180. So this is true, okay? So lines A and B are in fact parallel, okay? So if we're given that the lines are parallel, we know that these relationships work, but sometimes we have to test the relationships to see if the lines are parallel, all right? Let's take a look at some of these. All right, so knowing that these angles here are supplementary, okay, and that, you have corresponding angles here, and that you have corresponding angles here and here, okay, I know that these lines are parallel, but what we can tell, all right, is that we can, trying to find angles 1 and 2, given the rest of these, I can use alternate exterior angles to figure this out. So I can then say that angle 1 is an alternate exterior angle to 48. So angle 1 is equal to 48 degrees, okay? I can also then say that angle 2 is an alternate exterior angle to 132. All right, so angle 2 is equal to 132 degrees. And you can also use the concept of vertical angles here to do it as well. It doesn't matter. And that's what's cool about this, is that depending on what you're given in this scenario, given one angle, you can find all the others. But I know that alternate exterior angles, if these lines are parallel, they are congruent, okay? So that's the idea. Those are the angle relationships. Let's look at some practice problems. Okay, so on this, what I have here is I have this diagram, okay? and we're finding missing angle measures. So in this problem, in the diagram, A is parallel to B, okay? So I'm going to come in here and just draw some arrows because those don't exist on that problem, okay? And I want to use the relationships that I know to figure out what's angle 1, okay? So what I'm going to do is I'm going to say, all right, well, in order for me to figure out what angle 1 is, I got to figure out what this angle is. But this angle is an algebraic expression. So the first thing I want to do is set up an equation to solve this for x, okay? So, and figure out what x is. Once I find x, I can plug it back in, figure out what this angle is, and then use the fact that these two angles are supplementary to find angle 1. So if I wanted to figure out what x is, I have these two angles here. These are alternate interior angles, and those angles are congruent. So I'm going to come in here and put an arc mark showing that those angles are congruent. So I'm going to set up an equation, 12x minus 9 is equal to 10x plus 15. Okay, and if I solve this equation for x, you can do this a number of ways. I'm going to add 9 to both sides. So add 9, and then we're going to get 12x is equal to 10x plus, what is that, 24? 15 plus 9 is 24. Okay, I'm now going to subtract 10x from both sides. Pen isn't working very well today. All right, so subtract 10x from both sides. 12x minus 10x is going to give me 2x, and that's going to equal 24. Okay, divide each side by 2 and by 2. So now I divide both sides by 2, and x is going to equal 24 over 2, which is 12. Okay, so once I have found that x is equal to 12, what I want to do is figure out what this angle measure is here. All right, and so what I can do is I can substitute 12 into this angle and figure out what that is. All right, so I'm going to do 12 times 12 minus 9. So 12 times 12 is 144, okay? Minus 9 is going to give me 135. So this angle measure here is 135 degrees, okay? And I figured out what that angle is. All right, now what I want to do is I want to use that information to figure out what angle 1 is. That's the goal. We're trying to figure out what that is. So what I know is that these two angles are supplementary. So the next equation that I would set up is that angle 1 plus 135 is equal to a total of 180 degrees. And if I solve for angle 1, I can subtract 135 from both sides. All right, so then I get that angle 1 is then equal to 180 minus 135, which is 45 degrees, okay? And that's what angle 1 is. So yes, you will have to do some algebra on this, and that's okay. But that's how I would solve this type of problem to then figure out what angle 1 is, okay? And I'm just using my angle relationships. All right, now this one is very interesting. So angles are, lines A and B are parallel, okay, indicated here by this statement, and then also indicated by the arrows here. C and D are also parallel, indicated by the arrows and by this statement. So I'm given one angle here, that this is 70.5. What I can now do is I can figure out all of my other angle measures using the concept of corresponding angles, vertical angles, supplementary angles, alternate interior angles, and alternate exterior angles. So when I have this, okay, 70.5 degrees, I can then figure out all of my other angles. So let me do this, all right? I know that this angle here is going to be, I'm going to use red, so 70.5 is that angle here. Okay, I know that that corresponds with angle 11. Now, angle 70.5 is alternate exterior angles with 9, so that's congruent. And that 11 and angle 13 are alternate interior angles. Now, I could also use that they are vertical angles as well, okay? But then the same thing applies over here. Okay, 70.5 corresponds with angle 7. That's also the alternate interior angle to 13, so those are congruent. Angle 5 is vertical to angle 7, or you could say that it corresponds with 13, or you could say that it's alternate exterior angles. Doesn't matter. Okay, but then I can just come up here and go, okay, angle 1 and angle 5 correspond, angle 3 and angle 7 correspond. Boom, we're done. Now, I can then just say that all the other angles are going to be congruent to all the others. Okay, so those that have 2 arc marks, all right, and just want to figure out what those are, okay? But what I know is, okay, if this is 70.5 degrees, doesn't matter which one I look at, but I can look at angle 15 or 14, these angles have to add up to 180. So let's set this up, all right? Let's do angle 14 plus 70.5 is going to equal 180. So if I subtract 70.5 from both sides, okay, minus 70.5, all right, that's going to cancel out. So angle 14 is simply going to be 109.5, okay? And so that's what angle 14 is. So I'm going to come in here, and I know, and I'm just going to write this in, that this is 109.5 degrees, okay? Knowing what those are, I can now find the measure of each angle. So let's go through the red ones first, okay? Angle 1 and 3 are 70.5, so this is 70.5, 70.5. 5 and 7 are red, so 70.5. 70.5, 9 and 11, so 70.5, 70.5, angle 13, all right, angle 13, and then that's it, 70.5. Okay, all the other ones are going to be 109.5, so angle 2 is 109.5, angle 4 is 109.5, angle 6 is 109.5, angle 8 is 109.5, angle 10, 109.5, angle 12, 109.5, angle 14, 109.5, and angle 15 is 109.5. So again, given one angle in this situation, okay, I can then, provided that these two lines are parallel, or at least I have, you know, if I don't have 2 pairs of parallel lines, but I have 1 pair cut by a transversal, all I have to do is use my rules to then find those other angle measures, okay? And that's the idea. So that's all I got for this video. Hope you enjoyed it. Hopefully it's not too long of a video, but we'll talk soon. Thanks a lot. Bye!